Okay, so let's start with a drawing like this, where we take a triangle with sides ABC and angle gamma, and we put it on an XY axis plane. So everybody draw that picture real quick. Draw that. Not too hard to draw. Make sure it's angle gamma that's at the origin. So I know it looks kind of like an alpha, but gammas look like alpha is standing on their head, right? So this is gamma. Okay, so what we're going to do is try to write down the coordinates of the 3 points. So talking about the vertices here. What are the coordinates of the vertex at angle gamma? 0, 0, right. No big deal. What are the coordinates of this point over here? Don't shout it out. Write it down. What are the coordinates? Like, what are the XY coordinates of that point there? Right here. See if we can write it down. It's on the x-axis, so that's a clue. Okay, class, so what are my coordinates here? B, comma, 0, right. You go right, B, stop. Right on the x-axis. So that's B0. This is the tricky one up here. Now we know that if a point is on the unit circle, the coordinates are just cosine sine of this angle, right? If it's on the unit circle, this would just be cos gamma sine gamma if this were the unit circle. But it's not the unit circle, it's on the circle with radius A. So there's like a circle right here, radius A. So it is not cosine gamma sine gamma. Does anyone know what it is? A cosine gamma, A sine gamma. It's been stretched out. Okay? So this is just A cosine gamma, A sine gamma. It's really important you know that coordinates on the xy plane can also be written as distance to the origin times cosine of the angle, comma, distance to the origin sine of the angle. Super important for chapter 8 especially. Okay, really important. Okay, now we have the coordinates of all 3 corners. Let's go ahead and write down the distance formula between these 2 blue points. How do you write the distance formula? Trying to get the distance between those 2 points. You guys remember the distance formula? It's an old Algebra 1 formula. Has a big square root in it. Square root of x2 minus x1, and then that's squared, right? And then y2 minus y1, and that's squared. Okay. It's going to look a little awkward, but we have x's and y's here. Okay, so what are my x's? A cos gamma and what? B, right? And what are my y values? A sine gamma and 0, right? And all of this is equal to the distance, the length of this blue segment, which is called what? C, yes. Okay, so C is this. Let's square both sides because I really hate radicals. So let's just write it as C squared equals A cos gamma minus B squared plus A sine gamma. I'm not going to write minus 0. That's silly. This is the law of cosines. We can clean it up a little bit. Okay? C squared equals
we have a squared cos squared gamma minus 2ab cos gamma plus b squared, I foiled, minus a squared sine squared gamma. So I just want to remind you that when you FOIL something such as, a cos alpha gamma minus b, you actually need to do 2a, like 2 times this and this. That's where I got this term here from. I don't know why I put minus a squared sine squared gamma. That should be plus. Okay, guys, what is cosine squared plus sine squared? 1, right? So what is a squared cos squared plus a squared sine squared? In other words, these two green things, if cosine squared plus sine squared adds up to 1, then what does a squared cos squared plus a squared sine squared add up to? A squared. In other words, you can factor an a squared out of those two terms, right? See that? I just took an a squared out of those, the first and third terms, or the first and fourth terms. Okay, so what is cosine squared plus sine squared? That's just 1, right? Okay, so all of this just basically becomes this. C squared equals, the two underlined green things that I have there is just a squared. And then there's a plus b squared. And there's also this minus 2ab cosine gamma. This is the law of cosines in its simplest form. Like, you can't really get any simpler than that. And this thing looks kind of like the Pythagorean theorem, doesn't it? If I cover this part up with my hand, see the Pythagorean theorem there? In other words, if gamma was 90 degrees, remember cosine 90 is 0? This would just disappear. We'd be back to the good old Pythagorean theorem. So this rule right here that you see will supersede the Pythagorean theorem. You can throw the Pythagorean theorem in the trash now. You never need it for the rest of your life. This will take care of it. And when gamma is 90, it'll reproduce the Pythagorean theorem for you. Okay, there are 3 ways to write this. And notice I put angle gamma at the origin. I could have put angle alpha at the origin. I could have rotated the triangle and stick it that way. Or beta. So there's actually kind of 3 ways to write the law, and they look like this. The first one is a squared equals b squared plus c squared minus 2bc cos alpha. The second one is b squared equals a squared plus c squared minus 2ac cos beta. Can you write the third one? We actually just did a moment ago. Without peeking your paper, can you fill in the third one? Give you 30 seconds to fill that in. You need all 3 of these, okay? Notice it goes A, B, C, B, C, A, right? B, A, C, A, C, B. So did anyone figure out the third one? Maybe you can say it. What do you think it is, Tim?
A squared plus b squared minus 2a times b cosine c.
That's right. It's right there. By C you mean the third angle, right? Gamma? Yeah, gamma. I told you some people pinch their gamma together so it's kind of like a Y. I've been looping mine. But computer fonts typically pinch on the right at the bottom. Almost looks like a Y. Okay, so this right here is our last tool, and it also can solve right triangles. So I just want to say this one more time. SOHCAHTOA, Pythagorean theorem, those rules you can throw them in the trash can because both law of sines and law of cosines can handle right triangle. Okay? Just make your gamma 90 and you will never need those rules again. So that's kind of neat. I bet Pythagoras wished he had come up with these instead of his theorem because these are more versatile and they work on all triangles, not just the right triangle, see? Okay, so all we need is just a couple of examples of this, and then that'll be sufficient. I just want to remind you that this rule is used for SSS and SAS triangles, which were the last 2 that we were talking about the other day. We said we can't do those with the law of sines. So this is good for SSS and SAS type situations. Okay, let's try this, just some examples. Okay, so for my first example, we'll do an SAS case. We're going to let A be 2 and B equal 4, and gamma will be 47 degrees. Now you can tell that this is an SAS just by looking at it. See how it has 2 English letters and 1 Greek letter? And that Greek letter is neither of the English letters. So this is not alpha or beta, it's the 3rd letter of the Greek alphabet. So it's A, B, C, but the C is in Greek, is what I'm saying. That's always an SAS when you see them. And you should know right away when we use law of cosines for this. On my test, it's not going to say, solve using SOHCAHTOA. It won't say that. It won't say, solve using law of sines. You need to determine which law is best for you. Okay? If you try to solve this problem with law of sines, you will reach a dead end very fast. You won't be able to do it. So then you're like, okay, let's try law of cosines. Or you can say, look, I recognize this. This is SAS case. We have A, B, C, and the C is in Greek. So you should bust out the law of cosines. Yeah?
Can you use the law of cosines for a law of sines problem?
Not really. Because you know 2 angles, and the law here only has 1 angle per formula. See it? Alpha, beta, gamma. Last period, I just was for fun trying to set up the warm-up problem. We're trying to do the warm-up problem over there. Go away. I don't want this here. We're trying to do the warm-up problem with the law of cosines, and we just kept getting stuck. Like there's nothing you can do with them. Unless you have like the quadratic formula. Nobody wants to do that. So. Okay, so let's look back at our law. Which of the 3 would be best for us? We have little a and little b, and we have angle gamma. So which of the 3 would be best for us? The 3rd one has a gamma in it, right? It's the only one. So since we want to use our givens, let's use the 3rd one. So let's use c squared equals a squared plus b squared minus 2ab cos gamma. So you have c squared equals 2 squared plus 4 squared minus 2 times 4 cos 47. And if you type all this in, I think you get 3.01. Don't forget to square root, right? Pretty important. So 4 plus 16, basically minus 16 cos 47. That's 9.08. You have to square root. It's 3.01. So I'm just going to write a reminder, don't forget square root. Okay? So that wasn't too hard. In fact, the law of cosines is pretty easy to use. Okay, now, some people disagree with me on this next part I'm about to say, but I suggest that if you're doing a law of cosines problem, that you stick with the law of cosines and finish the problem with the law of cosines. Some people like to now use the law of sines to finish the problem. I found that out of about 4 times out of 100, not often, but sometimes I would get the wrong answer when I do that. And the reason is, right now we are in an SSA scenario. We have 2 sides and an angle, and if you try to use like B, C, and gamma to find alpha, alpha, then you're going to be stuck with an SSA scenario, and you might get the wrong answer choice. So what I'm saying is, let's just stick with law of cosines. It'll never go wrong. Okay, it's the safest thing to do. Let's just use a different version of this now and try to get either alpha or beta, right? Okay, so why don't we try the first one, this one. We haven't used that yet. Okay, so let's use another one. Maybe a squared equals b squared plus c squared minus 2bc cos alpha. You see I put a little dot before my cos alpha. You'll see why in a minute. Okay, so if you put in the numbers, we have 4, 16, c squared is 9.088. I can still see it on my calculator screen, minus 2 times 4 times 3.01 times cosine alpha. Okay, so you can do certain things, and there's certain things you can't do. Like, you're welcome to add these two together. That's 25.088. Okay? And you're welcome to do 8 times the 3.01. In other words, this is 24.117. But do not try to combine the 25 that you see here and the 24. There is no 24 here. It's a 24 cos alpha. You have to be very careful not to combine these two terms. This is a constant term. This is a variable term. You need to subtract the 25.088 to the other side and divide. Okay? A lot of students make this mistake. They try to subtract these two numbers right here. You can't do that. Okay. Instead, subtract 25.088 to this side, which of course gives us negative 21.088. Then we divide like this. So what's negative 21.088 divided by 24.117? Positive, right? 0.8744. And then we do an inverse cosine. Okay, I'm getting 29 degrees, right on the money actually, 29.02. So 29.0 is my angle. And the third angle of the triangle, well, you can just use 180 minus the two angles you have. So we now have gamma and alpha. Beta is easy. It's just 180 minus the original 47 degrees I gave you for gamma, minus 29.0. .97, basically 104. Did I do that right? Question?
I saw for beta first, and I got 104.1, and then I
Let me
got
check my calculations on that last cosine step. Actually, I don't trust my work on one of my steps here. I don't trust my inverse cosine work here. Did you get 29.0 at all?
I did. Oh, well, I got beta first, then I had for alpha 28.9.
Oh, okay. I think if you round it to the nearest tenth, isn't it still 29.0?
No, I had 28.9.
Okay, I'll be more careful next time. I'll be more careful next time with it, but just so you see that we use the law of cosines to get the third side, and we use the law of cosines to get one angle. And since we already knew another angle, we just use 180 minus the two angles to the third angle. Okay? And then you should make a little box like this for me with all the answers, all 6 parts organized. Okay? Okay. I'll be more careful next one. Let's try an SSS real quick, and then that'll end our lesson. So let's say that you were given A equals 2, B equals 4, C equals 5. Solve the triangle. This one's actually a little easier because there is no preferred formula to start with. If you use this rule, a squared equals b squared plus c squared minus 2bc cos alpha. If you use that one, you'll find alpha first. If you use the second version, you'll get beta first. If you use the third with the 3 formulas today, you'll get gamma first. It just doesn't matter. So this one's just a little easier to start off. You don't even have to think. Just grab any formula and start at it. Okay, let's put in the numbers. This would be a 4, and this would be a 16, and this would be a 25. This would be a 2 times 4 times 5. So we get 4 equals 41 minus 40 cos alpha. Am I going to subtract the 41 and the 40? No, right? We're going to subtract the 41 to the other side, right? So we get negative 37 equals negative 40 cos alpha. So cosine alpha is 37/40ths. You just do inverse cosine of 37/40ths. 22.3 degrees. Okay, when you're done with that one, you can pick a different version of the law. For example, now you can do b squared equals a squared plus c squared minus 2ac cos beta. And this will give you angle beta. So now it's 16 equals 4 plus 25 minus 2 times 5 cos beta. In other words, 16 equals 29 minus 20 cos beta. Subtract the 29, and we get negative 7 equals negative 20 cos beta. In other words, cos beta is 7/20ths. And just do an inverse cosine of 7/20ths. 69.5 degrees. Oh, except the 16 minus 29 is negative 13. Sorry. Let me fix that. I wrote that wrong. This is negative 13. So this is 13/20ths. Sorry, going a little too fast there. So inverse cosine of 13/20ths. 49.5, not 69.5. There we go. And then how do you find the third angle in a triangle when you know two of them? Just 180 minus the 2 that you have, right? So gamma is going to be 180 minus the 22.3 minus the 49.5. (108.2). So gamma is 108.2. So I always thought the SSS was easier because there's no preferred formula to start with, and you only have to run this twice. I will say it one more time, many students like to start with the law of cosines, and once they get an answer, they like to switch over to the law of sines, and it works 96% of the time, but it will fail you sometimes. There's a way to prevent it from failing, but I don't want to teach it. I say just start with the law of cosines, continue with the law of cosines, finish with the law of cosines. Okay? Stick to one law, you'll be safe. Okay, so there's the lesson, and then you guys can work on whatever for our last couple minutes.